Hi, and welcome to the Magic of Mathematics with Mrs. Arnold Harsley. We will be looking at area, and in particular finding the area of a triangle using Heron's formula. So today's objectives are to refresh what perimeter and area are, what is the semiperimeter, what is Heron's formula, and then how to find the area of a triangle when all side lengths are given using Heron's formula. Okay, so the definition of perimeter is the total distance around the outside of a shape. So what that means is you're measuring the distance, let me just grab a pen, along that edge, along that edge, and along that edge. So if each edge, for example, is 5 centimeters, the perimeter of that particular triangle would be 5 plus 5 plus 5, which is 15 centimeters. So perimeter is measuring the distance around the outside of a shape. Area, just grab a different pen, measures the space inside a shape. So area will measure this here, everything that's inside that shape, that part there. That's what we're measuring with area. So again, if we've got a triangle and it's 5 centimeters here, and you would usually be given the height 5 centimeters, and the height is, let's say, 6 centimeters, then you would use the standard formula for measuring the space inside that shape for area, which is usually written as half BH, which is half multiplied by base multiplied by height. I prefer base multiplied by height and then divide it by 2 because you're halving it. So that would be, the base is 5, the height is 6, you divide that by 2, which gives you 30 divided by 2, which also gives you 15 centimeters squared. It's because it's an equilateral triangle, so all the sides and all the internal angles are equal. So the distance around the outside edge for the perimeter is 15 centimeters. The area of this triangle, because we've been given the base and the height using the standard formula, is 15 centimeters squared. So what is meant by the semiperimeter? So first of all, we've just defined the perimeter as the measurement around the whole outside edge of a shape, in this case a triangle. The semiperimeter is half the distance of the perimeter, so it's half of the perimeter. Finding the semiperimeter of a triangle is the first step in a two-step process to find the area of a triangle using Heron's formula. So to find the semiperimeter of a triangle, you find the perimeter first. That's here. Let me get my pen. And then you divide the perimeter by 2 to give you S. So S means semiperimeter. So it's got A plus B plus C. So each side of the triangle is labelled A, B or C, and it doesn't matter where the A, B or C go, so they can be in different places. It doesn't matter because when you add, it's a word called commutative, which means you can do it in any order you like and the answer will still be correct. So let's use the 5 centimeter measurements that we used in the previous slide. So first of all, we have to do this. Add A plus B plus C, so that's 5 plus 5 plus 5, which is 15 centimeters. And then we do this. We take that perimeter and we divide it by 2, which means you halve it. And half of 15 is 7.5 centimeters. So therefore, I'll write it over here, S, which is the semiperimeter, is 7.5 centimetres. Heron's formula was named after Hero of Alexander. Just grab a pen. That's a little picture of Hero right there. He was a Greek mathematician and engineer. So the formula requires the semi-perimeter of a triangle, which we've just established, and each side of its lengths, which was A, B, and C, in order to solve for area. So Heron's formula is here. To find the area, you have to take the square root of S, which is a semi-perimeter, and then multiply it by S subtract A, which is one of the sides of the triangle, multiply that by S subtract B, and multiply that by S subtract C, where A, B, and C are the three sides of the triangle, and all of these S's represent the semi-perimeter. So let's look at a worked example. Here we've got a triangle with side lengths 6 centimetres, 9 centimetres and 11 centimetres. So I'll just label it A. That can be side B and that can be side C. Again, remember it doesn't matter which side is A, B or C. We've got Heron's formula and we've got the semi-perimeter. So remember it's a two-step process. The first thing we need to do is find the perimeter so we can work out the semi-perimeter. So we need to add A, B and C together. So the perimeter will be 6, add 9, add 11, which is 26 centimetres. And then the semi-perimeter is the perimeter divided by 2. So it's 26 centimetres divided by 2. Which is 13 centimetres. So now we have S, our semi-perimeter, equals 13 centimetres. Now we need to pop everything that we have, all of the values, into Heron's formula here. So we've got S, the semi-perimeter. We've just calculated that to be 13. We've got A, which is 6 centimetres. We've got B, which is 9 centimetres, and we've got C, which is 11 centimetres. So I'm going to write area equals and just pop those values into the formula. So S is 13. And we open the brackets and we do this part here, which is 13 subtract 6 from here. That's where we got the 6 from. And then open the brackets again for S subtract B. So S is 13, subtract B, which is here, that's 9. Open the brackets for this part of the formula, which is 13, the semi-perimeter, subtract 11, which is there. So the next stage is to work out the parts that are in the brackets. So order of operations says we need to do brackets first. So I'm going to carry down this 13 here. We're not doing anything with that yet. We're just working out what's in the brackets. So 13 subtract 6 is 7. 13 subtract 9 is 4. And 13 subtract 11 is 2. Now in between here and those brackets are invisible multiplication signs. So we're going to take the brackets away and write it out again with the multiplication signs in so that it makes more sense. So now the area is the square root of 13 multiplied by 7 multiplied by 4 multiplied by 2. So you just pop 13 multiplied by 7 multiplied by 4 multiplied by 2 into your calculator and you should get 728. So now you put square root, use the square root key in your calculator followed by 728, and the square root of 728 is 26.98 centimetres squared. So that means 26.98 centimetres squared is the area that I'm shading here inside of this triangle, calculated using Heron's formula. So today we looked at perimeter and area and refreshed our knowledge on the definitions of both of those, where perimeter is measuring the outside edge of a shape and area is measuring the inside of the shape. We discovered what is meant by the semiperimeter. The semiperimeter is half of the perimeter. And we found the area of a triangle when all side lengths are given using Heron's formula. So thank you for watching. It's Mrs. Arnold Harsley with the Magic of Mathematics. Until next time, see ya.